Hi, welcome to the presentation on differential equations. Some of the equations can be transformed to one in which variables are separable. Let me consider one example. I'm writing the general form dy over dx is equal to phi of ex plus by plus c. Here right hand side is an expression involving x plus by plus c. It can be, I will give you an example. This function, it can be like e power 2x plus 3y plus 5. This right side can be like this, or it can be x negative 2y plus some constant 6 whole power 3. It any it can be in these forms. So I wrote generally the right side is a function like this. This ax plus by plus c is a linear function. If we have a differential equation like this, to reduce this to variable separable form, we have to make a substitution, that is ax plus by plus c is equal to v. With this substitution, we can reduce this differential equation to variable separable differential equation. I will illustrate that by considering one simple example. The question says to solve dy over dx, which is equal to 3x plus 2y plus 4 whole power 2. Now, this is of the form, this right side is of is contains 3x plus 2y plus 4 whole square, and even if you try to make the coefficient of dx as x alone, we may end with the difficulty. We can't write the coefficient of dx as function of x. So in this scenario, what we can do is change this linear function, that is 3x plus 2y plus 4, to some variable. Let me take v. Now differentiate this with respect to x. So d by dx of 3x plus 2y plus 4, which is equal to d by dx of v. Now uh, derivative of x with respect to x, it would be 1. So 3 times 1 plus 2 times derivative of y with respect to x is dy over dx, plus derivative of constant, it is 0. This in the right side we have dv over dx. Now this dy over dx is equal to dy over dx is equal to dv over dx negative 3 times half. You can write half first, that is not a problem. Now in the place of dy over dx, we have to write this term. So dy, in the place of dy over dx, I am writing half times dv over dx negative 3, which is equal to v square. This is important step. See here, in the place of 3x plus 2y plus 4, I am writing v. Now take this 2 to the right side. So we have dv over dx negative 3 is equal to 2v square. Then this positive 3 to the right side. dv over dx is equal to 2v square plus 3. This is a variable separable differential equation. We can separate the way where the coefficient dy as v alone, the coefficient of dx is x alone. Now cross multiply. Let me write here. So we have dv over dx is equal to dv over dx is equal to 2v square plus 3. Then 1 over 2v square plus 3 times dv is equal to dx. Now integrate on both the sides. So 1 over 2v square plus 3 dv is equal to dx. Now our task is to integrate the integrand 1 over 2v square plus 3. This is very important step. We know that integral of 1 upon a square plus x square dx as 1 over a tan inverse of x over a plus c. The coefficient of x square here is 1. It is 1. But here we have 2. This 2 should not be there. So what I do is I take 2 as a common in this term and this term. So I am having integral 1 upon 2 times v square plus 3 over 2 dv, which is equal to integral of dx. Now half of dv over v square, this 3 over 2, to write exactly this in this form, what I do is I write 3 over 2 as root 3 over 2 whole square, then integral of dx. That's x I'm writing here now. So here is a is equal to root of 3 over 2 and x here is v. Okay, now we have to plug in x and a value in the standard result, that is integral of 1 over a square plus x square dx. So this is equal to 1 upon root of 3 over 2 times tan inverse of x over a. In the place of x we have to write v over a is root 3 within a square root 3 over 2 plus some constant c. In the place of v we have to write 3x. What is our, we have to write v as v is equal to 3x plus 2y plus 4, and I will simplify this further. Let me write in the top. I am, oh no space, oh yeah, here is there. So 1 over within a square root 3 by 2, this is equal to root 2 over root 3 times tan inverse of root 2 over root 3 over root 3 times v. V is nothing but 3x plus 2y plus 4. So here I'm writing 3x plus 4y plus 2 plus some constant k. This is the final answer. Thank you for watching this video. In the next presentation I keep on doing the problem.